Our next property is the identity element. Right. If in a set S with operation star, there exists an element E also belongs to what? The S, such that for all S belongs to S. So we are saying that E star S, we will get what? S. Then S star E, we will get S. That's what we are saying here. Then E is said to be an identity element for operation star. Okay, so we should take note of this. The identity element is always unique. The identity element under each operation is unique or a constant. Normally we get a constant number and then it's unique. Okay, unique means what? One. So it's unique. Okay, an operation star has an identity element if and only if it's commutative. We are talking about commutative. We are saying that commutative A star B equals B star A if they are the same. So here E star S the same as S star E because all of them will get S. So therefore it's what? Commutative. 0 and 1 are identity element under addition and subtraction, addition and multiplication of real numbers. Why are we saying that? Okay, in 0. So 0 plus, in addition, 0 plus 1 is what? Yes, 1. 0 plus 2 is what? 2. 0 plus 3 is what? 3. You see that if we add them, we still get any number added to 0, you get the same number. So meaning 0 is what? Identity element. And addition and multiplication, we are saying that 1 is identity element. Yes. Any number times 1, you get the same number. That's why we are saying that in multiplication, 1 is an identity element. 1 times 5 is 5. 1 times 6 is 6. 1 times 9 is 9. That's what we are saying here. The identity element. Let's solve some example here. So like I said, we'll be solving 2 examples under each of the operations. So please visit our previous video and just subscribe to Senior Perus, my YouTube channel, for more videos. This is our example here. The operation star is defined over the set R of real numbers by this our definition here. Okay, find the identity element under the operation. So here we are finding the identity element under the operation. Okay, so this is our definition. So by definition, solution. This is my definition. The definition here, A star B equals A plus B plus AB. Okay, and they say we should find the identity element here. And we said the identity element is commutative. Okay, so meaning, and we said we represent our identity element as E. So let E belongs to real numbers be the identity element, like we said earlier, always our E. So we represent the E as an identity element. You can play the never, but normally we represent that one E as identity element. It's not by force. Okay, so let E belongs to R be the identity element. So therefore, then A star E is A, like we said earlier. Like we said, additions are the identity element 0. So 1 plus what? 0 is 1. So A star E is A. E star A is what? A. That's what you are saying. That's why I said identity element is commutative. Now I know the reason. So you will start with A star E equals A. Right? You should find identity element here. So you can use the second one. You can use this one. So we should find the identity element there. Now, from our operation here, the definition A star B is called A plus B plus A. Now, our A here is still our A. Now, our B have changed to what? E. So, whenever you see B, just put E there, like we are doing for the previous in our previous video. So, we just put into the definition, like we said. So now A E, it at first was AB. So whenever you see B, just put E there times AA. AB, okay, equals what? A. We were looking for the identity element, okay, so we want to make the E the subject. So let our A is the E the subject. So we subtract A on both sides, then we get this. By subtracting A on both sides, we get this. We still want E. So what should I do? Let's factorize the e out so that we will get what? We factor the e out, we get 1 plus a equals this one is 0. Okay. Now you still want our e, so our basic algebra, what should we do? We should divide both sides by 1 plus a. So we divide both sides by 1 plus a. This is what we get. Okay, therefore our e is 0. So our identity element here is 0 under the operation star. As easy as that. Let's solve the next example. Example 2 on identity elements. So this the next example. The operation is defined over the set of raw numbers by this A operation B is defined as 1 minus 2ab. Find the identity element under the operation this, operation sign this. Okay. So by definition, this is our definition, right? So we get a definition. Please always remember to write the definition. It will fetch you a mass. Okay. So this by definition, we should find the identity element. We know the identity element here will normally represent E. So let E belongs to R, that's the real numbers, be the identity element. Okay. So we can write A operation E or E operation A equals what? A. Anyway, anyone you want. So A operation E is equal to A. This is what we say about the identity element. So now just go into this as easy as that. Right? Then we know that our A is what? A, and our E is what? B. So this is the definition. So anywhere you see A, just put A there. Anywhere you see E, just put what? Anywhere you see B, just put E there. That's why we have the equals the A. So that's by definition. Now we know how to solve this. We say we are looking for E, so we just make E the subject. Okay. So just move here. You can plus E the subject. So what should we show? Move the A here. If factorize the E will also, let's move the A here, or you subtract A on both sides. Okay, we want E, we are finding for E, that's identity element. Okay, don't go and factorize. How you find the E? So just move here. Now we can find E here. What should we do? We should divide both sides by 2A so that we can find our E. We did this basic algebra at the basic level. So therefore, our identity element is this. So this is not unique. Okay, it's not what? A constant. And the first example was a constant, this was unique, but this one is not unique. So this one, the identity element here is not unique. Okay, so therefore, our identity element does not exist since E is not a constant. So it's not unique. So find the identity element of 3. So this one is not unique, it's not a constant. So our identity element does not exist since E is not a constant. Now you understand the reason I've said that identity element should be unique or a constant under the operation. Okay. Our next property is the inverse element. Okay. Since we are done with the identity element, we can deal with the inverse element. Now, if a set S on which an operation star is defined has an identity element E, please let's be careful here. So it has an identity element E, and if S is an element of S, then an inverse of S is any element S to the power -1 such that S operation S to the power -1 equals E. Okay, so S to the power -1, that's so the inverse of what? S. Okay, that's what we are saying. That's an inverse of S is any element. That's what we are saying. So S star inverse of S is identity, equals the identity. Okay, so before you wait for an inverse element, you have to know your identity. So you have to wait for the identity before you can wait for an inverse element. Okay, or we are saying that the inverse of S star S will give us identity. So if you can check them, we still get what? Identity elements. So if you take note of the inverse here, if S inverse is an if S to the power 1 is an inverse of S, then S is an inverse of this. Okay, that's what they are saying. So this is an inverse of S, then S2 is an inverse of this. That's what we are saying here. Just take note of that. An operation star has an inverse if and only if it have an identity element. That's what I said earlier. So let's solve example on the inverse element. And I said earlier, before we solve the inverse element, let's know the identity element before we solve the inverse element. So this is our example. Example 1. Yeah, this similar question, we solve it in the inverse element as example 1. Okay. The operation star is defined over the set of R of real numbers by this. Find the inverse under operation star and state which element has no inverse. Good. Then we solve this one. Before this, I said that the inverse, you have to know the identity element. So solution. By definition, but we have solved this one using the definition with the identity element. In our previous video lesson, we solved the identity element with this one. We got E equals 0. You can go back and watch. Okay. So let A to the power 1, the inverse represents what? Of real numbers, be the inverse. So this one, A to the power -1, represents the inverse, be the inverse element. Okay. Then A operation A to the power 1, that's the inverse, is equal to the identity. This is what we said. A star, the inverse of A, is equal to identity. This is what we said in the definition. So we have to know the identity element. So we can find the identity element from here. But we have already solved the identity element in the previous video. So we know that the identity element was 0. That is our previous example that we saw, example 1. We got the identity element as 0. But E is 0. In our previous video, with this definition, please, with this definition, we solve it in the identity element as example 1. Okay? We can go back and watch that one too. Then A, so like we said, with this operation, our A here is what? A. And the inverse of A is now our B. So we just substitute into this definition. That's what we did here. So A plus A inverse. So the A inverse, that's now B. So B is now our A inverse times A times A inverse, which I've already explained. And we say our identity element is 0. So if you solve this one, you get an identity element as 0, which we have already solved. So solving for the inverse, here we are solving for the inverse, not the identity element. So we are solving for the inverse here. So since you want to solve for the inverse here, let's make the inverse the subject. So by that, we have to subtract A on both sides or remove A to a whole equal sign. So this is what you get. So now you have inverse and inverse here. We want the inverse. So let's factor the inverse out. So it will be 1, the inverse of A times 1 plus what? A equal -A. We want the inverse. So therefore, our inverse -A out of 1 plus A. And the question said, state which element have no inverse. Okay, it means that we have to create the denominator here to 0. This one we talk about under rational function. So we want to state which element have no inverse. So we are stating for the 0. So we just create the denominator by what? 0. So by creating the denominator, so this is the inverse of A. You create the denominator to 0, you have A equals 0. Therefore, our A is a -1. So state which element has no inverse. So -1 have no inverse, because if you put -1 here, it will be 0. So this one beats something. So that's why, therefore, the real number -1 has no inverse. As easy as that. So with example 2, this is our definition. The operation days is defined over the set R by that definition. Find the inverse under the operation and state the element which has no inverse. Okay, like the similar one. Like I said earlier, so by definition, like I said earlier, is that before you solve for inverse, we have to know your identity element under the operation, under the definition. Okay, so this one we are not solved for it. So we solve for the identity element before we can solve for the inverse. The previous example, we already solved for the identity element. That's why we said identity element is 0. So now this definition. So let E be our identity element. Without it, we cannot solve for the inverse element. Okay, because the inverse element will give us the E. Then A O plus E equals A. So A, that's operation sign here. A. We said that the inverse element A operation E is the same as the same number. That's what we talk about it here. So therefore, we just substitute this one into a definition. Now our A is still A. Our E here is what? B. Okay, so anywhere you see B, just put E there. Simple as that. So this is the definition. That's why we got 3AE equals A. So we are solving for the E. So let's make it a subject. So I think if we make it a subject, let's divide. We want to make it a subject. So we divide both sides by 3A. Okay. So the 3A will cancel. So that's why we got E here. So I think the A2 will cancel. So our E is what? 1 out of. Our E is 1 out of 3. Good. As easy as that. So our E is 1 out of 3. Okay. So this is now our E. These are now our E. That's our identity element. Now, let's solve for the inverse element. So let A inverse be the inverse element. So therefore, A operation A inverse is equal to the identity element. Now, I know the identity element is 1 out of 3. And now we are going to substitute this one into the equation. So our A is still A. Now, our B is now what? A inverse A inverse, that's what? 8 upon negative 1 into this definition. So it will be 3A times A inverse. So, but our E is this, which I already said earlier. So we just have it. So 3A, our B is what? A inverse equals what? The identity element. So we are finding the inverse element. So we are finding the inverse element, okay? So like we said earlier, so we want it, so we divide both sides by what? So we multiply it, we divide both sides by the 3A. That's why we divide, so we divide both sides by 3A. So we divide it by 3A, they divide by 3. That's why we got 3 times 3A. Okay, so if you multiply it, so we got 9A. So therefore, our inverse element is this. So state which element has no inverse. This one, its inverse is this. So if state one has no inverse, so if you equate this one to 0, what will be our A? So this one, it has no inverse.